Welcome to option video number 10. Well, we need to be able to model an equilibrium option price. And so we're going to talk about a well-known option pricing model called the Black-Scholes option pricing model, named after two economists, Black and Scholes. And this model was disseminated publicly, I believe, in the early 1970s. And in fact, I believe it enabled the actual initiation of trading of standardized exchange-traded options in the US. So this was a big deal in the 1970s. Point being, not too long ago. Not too long ago. So here we have the Black-Scholes option pricing model, and we'll show it for both calls and puts. And so we start off with, it involves a few equations. So the first one is C for call, market price of the call, equals the stock price multiplied by a probability that is indicated in this manner, ND1, I'll break down the details in a moment, minus the strike price of the option times a continuous discount factor, e to the RT, and again, that's just a present value interest factor using continuous discounting, okay? And this is multiplied by another probability that's written ND2. And that's the equation for the call. I'll put the equation for the put up here now, and then I'll describe what these probabilities look like. So for a put, we have put equals minus S times N minus D1 plus X times e to the minus RT times N negative D2. Okay, so very similar. There are 4 points of distinction, and that minus sign is 1. I'll put little dots down there. This minus sign is 2, differing from the call. This minus sign changes to a plus, and this D2 changes to minus D2. So little dots just indicate what the differences are. And so that's the Black-Scholes definition for equilibrium value for a call and for a put. I have to make sure I mention that the Black-Scholes option pricing model is used to price European options. So this is used to price options that can only be exercised on their expiration date, not before. And so that gives us some problems, and we'll talk about those as we go through, but it's still a pretty valid and valuable option pricing model to use. Every firm that finds it necessary to estimate equilibrium option prices that uses the Black-Scholes model has to modify it because of the fact that Black-Scholes is a European option pricing model, and if you're in the US, most options are American options that can be exercised prior to expiration. So the model has to be modified, and it's modified in a proprietary manner, which means they're not going to tell you what they do, but we'll talk about that stuff in some detail in a bit. Okay. Now, ND1, ND2, N minus D2, and N minus D1 are probabilities. And specifically, they're probabilities from a standard normal distribution that has a mean of 0, of course, and a standard deviation of 1. And D1 and D2 are values on the horizontal axis of the normal distribution. The formula for the normal distribution, you've probably seen it before. This is a scaling factor that's used to take this, which is it's Gaussian is the word that comes to mind, and multiplying this by this ensures that the area underneath the curve in the limit is 1. And so this is the function that, remember, f of x is just the y value, the ordinate value, and it allows us to get an equation get a function rather, that graphs like this, that approaches the horizontal axis as we approach positive infinity and negative infinity, but never touches. And so the area under this curve in the limit is 1, and hence it can be used as a probability distribution. And again, this is the scaling factor. Okay, so for the purposes here, the mean is 0 and the standard deviation is 1. That's what this model requires. Okay, that D1 and D2 be values along the horizontal axis of a standard normal distribution. So if, for example, this is D1, okay, if, for example, that dot right there on the horizontal axis is the value of D1, then ND1 would be the area under that curve, which of course, since it doesn't include this, is some value less than 1. And so that is that area there, ND1, some value less than 1.0 and greater than 0. And that's what this Black-Scholes option pricing model wants for D1 and D2. If this is D1, then that point right there obviously is minus D1. And then its probability, I'll indicate in red, N of minus D1 would just be the area I'm showing here with the red opposite slash lines, okay? And so this red area here would be N minus D1, so nothing confusing there. You need to know that ND1, N minus D1, N minus D2, and ND2 are probabilities with values greater than 0 and less than 1, inclusive. Okay, so next, what is D1? What is D2? Well, I have to show you the equations. And D1, according to this pricing model, is the natural log of stock price over strike price plus the risk-free rate plus 0.5. I'm going to write a sigma. It's what I called EV in the prior video, expected volatility. So I'm going to put a sigma there, sigma squared T divided by sigma, the square root T. And so this is R plus 0.5 sigma square, end the parentheses and multiply by T. And that's D1. And remember, D1 is a point along the horizontal axis of a standard normal distribution. Okay? And now, as we look at this, we can see, hey, each and every one of the factors that the Black-Scholes option pricing model says are relevant in determining equilibrium option prices appear here. There's S, there's X, there's T, there's R, and there is sigma. Again, that sigma is the equivalent of what I refer to frequently as EV, expected volatility. Okay? So, now, Black-Scholes wants sigma measured as the standard deviation of annualized, continuously compounded returns. So again, the Black-Scholes model wants this sigma measured as the standard deviation of annualized, continuously compounded returns. At this point, I'll remind you that Black-Scholes model, the Black-Scholes model, wants T measured in years, and it wants R, the risk-free rate, in continuously compounded form. Okay? Well, what's D2? Well, D2 is almost identical to D1, except that plus sign becomes a minus sign. So it's the natural log of S over X plus R minus 0.5 sigma square T divided by sigma square root T. So that's D1, that's D2. And these are used to estimate the value of call and put options, specifically European call and put options. And that's the Black-Scholes model, and it's what we'll use in upcoming spreadsheets to allow us to chart option values and observe how they are impacted by different assumptions as to different values of S and R and expected volatility and time until expiration. So that's the Black-Scholes option pricing model, and that'll be enough for this video.